Lesson 8. So I believe this is this is the last lesson of the log part specific, and then we have 5 lessons on applications of logs. So this is a big unit. Like I said, expect this to be almost a double unit test, 13 lessons. So your previous weights were 7 and 8. This one's going to be 13, or you'll see 130 on your thing, but it's not important for the video. But anyway, so we'll investigate the y equals log base b of x in terms of what it looks like when you graph it. So in each of the following, complete the statement and sketch the graph in the grid of with the format. So we're going to go and skip that part for now because it's already here for us. This right here is y equals log 3 of x. But I think the important thing to understand is keep getting that pattern in your head of logarithms. So what I mean by that is, if I say we know that y, so log base 10 of x, it's not up here. But if it says goes to the point of 1, so 1, what's that mean? If I put a 1 here, what's x going to be? So remember, it's 10 to the 1 equals 10, right? It should be 10 again. Log 10 of 10 is 1, like that relationship with logs. So we know that this here would be 10. Okay, we'll do the points first, and then we'll kind of sketch them on here. Y equals log 1/3 of x. Passes the point 0, 1. So if 1's here, it'd be 1/3 of the 1, so it's 1/3. Log 1/10 of the x goes through 1/10. Whoops, that's not a 16, that's a 10. Okay, so 10, 1. Be there for that one. So log 10 of x is going to go, they actually all go through this point. Why do they all go through that point there? 1, 0. What's that? Yep, it is the x-intercept. That's correct. But remember, all logs have the x-intercept because why? You're right. The inverse of the exponential, all exponentials went 0, 1, right? So remember, exponentials all had 0, 1 on its graph, remember? And so logs are all going to have 1, 0. That's correct. So that's just you knowing your x and y flip. Good. But why? Well, let's talk about the exponents. Why was it 0, 1? Because remember, that was 3 to the 0 is 1. 6 to the 0 was 1. Anything to the 0 power is 1, remember? That's why that one was that case. Logarithms, just right there is fine. Okay. Yep. So logarithms, it's because log base 10 of 0, or sorry, log base 10 of 1 equals 0, right? Because 10 to the 0 power equals 1. So remember, we said that any logarithm of 1, any base, is going to be 0 every time. So that's why all of these graphs are going to go through that point right there. Now, we'll have some shifts today where we'll be off of that. But in general, they're going to go through that spot. So the log 10 of x, again, like I was saying, is right up here. 5. Oh, actually, I don't have it on the graph. They didn't graph these, so that's OK. We'll get to these other ones later. Sorry, it's 1/3 one way, 1/10. OK, so we're all good. So 1/3, 1. So 1/3, 1 is, there's about 1/3. There's 1. There's 1/10, 1. So you can see these 1/3 and 1/10 are coming down this way. Okay, they come down a little different direction because of their, they are flips. We'll talk about that too as we keep going. Okay. So the 1/10, so they're all going to kind of go like this, just roughly. 1/10, and then the 1/3. Roughly like that. The 10th, the 10 base x is going to go like this. Oh, nope, it's not steeper, sorry. And this is the part that we were trying to explain today that guys and gals are struggling with, was that the 10, everybody's like, okay, log base 10, wouldn't that be stretched more because the base is 10? Well, good idea, good thought, but think about it this way. Log base 10, if I do 10, think about log base 10. And let's just say, we don't know what this is for a second, and I put a 2 there. So that's at y equals 2, right? Okay, so it's 10 squared equals 100. So that means that 2 is all the way over here at 100. off the board. So the bigger the base, the flatter the line. Okay, because it's growing. Because what's happening is the exponents, as the exponents get bigger, that y gets super big. So 3 is steeper than 10 because 3 grows essentially in a more manageable rate. So like if I do log base 10 or 3, sorry, space, and I put a 2 here, 3 squared is 9. That's still on here, right? So if I do 9, it's right there. See it too? And so that's what I want to explain to you is that when you see the bigger bases, they're actually flatter. When you see the smaller bases, they rise faster. Okay? The fractions come in the other angle because they're negative. Because remember, 1/3 is really 3 to the negative 1, right? 1/5 to the negative 5. Okay? So anyway, we'll get that. Okay, so without using the graph calculator, sketch the graphs the following: log 5 of x and 1/5 of x. So actually, let's just go ahead and do these real quick. So if I do log 5 of x, I'll just put in the same grid here. Log 5 of x, again, these are both going to pass through here. Okay, so let's switch the color a little bit here just to get things. So 5 of x, so the 1. So if I write log base 5 of x, when that's 1, the y is 1. That means this right here, 5 to the 1 is 5. So it's going to be right there. And see how that 5 is slightly below the 3, like I said? Okay, now the problem is for 2, where's 2 going to be? 25, that's off my page already, right? And so I'm essentially going to be coming up through like this. There's your 5. Okay, your 1/5. So we do log 1/5 of x. Let's just do equals 1. So that's the, here we're going through here still because that's that same spot. So at 1/5 to the 1 equals 1/5, right? So that's going to happen right here. And so you can see it's coming down like this. And it makes sense though, right? Because what's happening is that 1/5 we understand is 5 to the negative 1, right? And so it's reflecting these. See how these, what do these look like they're reflected over? The x-axis, right? That's the next thing we're going to cover. Okay, so that 1/5 and 5 relationship, that flipping the negative 1 exponent, flips it over the x-axis. And we're going to talk about that in a second. Okay, but that's the graphs there. Let's see if I can get a better point because I just kind of guesstimated there on that sketch. Let's see, 2, if we put a 2 here, 1/5 squared is going to be what? 1/25. So that means I'm going to go right there, really close to the, right? 1/125 is really close to 0. Okay. Yeah. Okay, cool. All right, so complete this table here. So it's kind of things we just observed. So one thing that I want you to understand, all these logs, their domain has changed. Okay, their domain is not all reals like exponentials. Because where are they cut off at? All those graphs I just drew did not pass into the negative x's, right? So all of our domains are x greater than 0 for all those. So why? Well, exponentials could never have an output less than 0. So then the inverse says logs can never have an input less than 0. Okay? It's good. Range. The range is now what? Because it flips. What was exponential's domain? The XER. So this is YER for all those. Remember, we didn't have an x-intercept for exponentials, but we do have one for logs. It's always what? 1. So then y-intercepts, we know we don't have any, right? What's the asymptote of these log functions? What's that, Jake? X equals 0, yeah. The vertical, the y-axis, right? Because we're not crossing the y-axis. So that's my asymptote that we're not touching. Okay. X value and y is 1. The x value and y is 1. So that's kind of silly for these ones because when y is 1, that means 3 to the 1. 3. 10 to the 1. 10. 1/3 to the 1. So it essentially is the base. 1/10, and then that one's b. b to the 1 is b. Okay? All right, good deal. So now we're going to go ahead and just talk about that part we just looked at in the picture. We just said this, so how do the graphs y equals 3 of x and 1/3 of x compare? They reflect over the x-axis. Okay? How do the graphs of 1/10 and 10 also reflect over the x-axis? Just to make sure it's not a coincidence. And so then complete the following statement. The graph of y equals log of 1 over b of x is a reflection over x-axis of the graph y equals log b of x. Okay, if you're saying, well, wait a second, I thought negative f of x is what makes it flip. You're right. You're right. But let's see if that's the case here. Maybe you don't see that, but let's show you why that's happening. Okay? So here's the work that kind of shows that. So let's just say we have y equals, this is just in generality, so it's just variables, I don't have numbers here. Y equals log base b of x, right? And then we're going to go ahead and say, in order to reflect, remember we said we flip the y to negative. Remember? Negative f of x or negative y. So let's go ahead and do that. Right? That's what normally makes things reflect over the x-axis. And so by doing that, the line thing, this right here? B? Oh, yeah, yeah. Not a good one, sorry. There we go. And so then we'll move the negative over, right? And the negative would make it y equals negative log b. Wow, that's an awful b too. Negative log b of x, which we have right here is equivalent to this. Now, why is it equivalent? Let's actually go that extra step here. If we go back to this, if we think about this as negative, right? So think about this. If I go b to the negative y equals x, what do we do with that? We move it down. So that's how it gets to be 1 over b, okay, which proves this. Okay, so essentially that was just a little proof of why it's reflecting over the x-axis, even though it's not used to what you're used to seeing. Okay, but for you, simply 1 over b, 1 over the base, will give you reflection. Okay? Any questions? We're going to start hitting some examples now. I'm really talking about reflections, and we'll talk about a little bit of translations. So translations are the same as you've known before. Okay? Opposite for x, up and down for y. Okay, if log base 4 of x equals 8, state the value of log 1/4 x. Negative 8. Just flips, right? Just went from positive 8 here, flipped down over the x-axis to negative 8. Okay, by what we just learned. Okay, prove the result. So write the proof here real quick. So that's 4 to the 8 equals x. And then we go log 1/4 x equals v. We don't know what v is for right now. That's x equals 1/4 to the v. Then we know it's x equals 4 to the negative v. And so you can see if x equals 4 to the 8th and x equals 4 to the negative v, so that's just negative what's up there. Just proving your point of that being flipped. Okay, perfect. All right, let's look at this one here. Again, this is the part that was confusing for last class, and I said it backwards once right when they were starting to get it, so I won't say it backwards for you guys. Here's a good illustration that I was trying to explain to you. Notice as the log bases get bigger, the line gets flatter. Okay? I also want you to notice that it's steeper before. See how that goes here? Goes across there. Goes across there. It goes across there. So the log 2 of x is the steeper log in terms of the graph. Okay? Again, that's because it's growing at a rate that's it's more countable. It's kind of the easiest way to think about it. Okay? So let's go ahead and complete these statements. All right. You guys will have the picture there. I won't have it all the way, so we can complete these. I'll do right to there. Okay. So complete the following statements. Part 1. Log 2 of x passes through 8 what? So when x is 8, what is y? So essentially it's saying 2 to what power is 8? Right? Because that's an 8. So 2 to what power is 8? 3, right? So we put a 3 there. A little bit tricky one here. Log 4 of x passes through 8 what? So that's a little tricky because it's not a base of 8, right? So we got to do a little bit of work here. So we'll just do a little bit of work. If we said it'd be 4 to the y equals 8, but let's go ahead and write those both at the base of 2, right? Everybody okay with 2y? 4y, 2y? Equals 2 cubed, yeah? So then y equals 3 halves, because 2y equals 3, divide the 2. So this one is 3 halves. Okay. Keep trying these here. And then we know log 8 of 8 is what? 1. That's the easy one. Okay. So the graph of y equals log base 4 of x is a vertical stretch of the graph of y equals log 2 of x. So what they're saying is there's a vertical movement, right? They're vertically stretching differently. Now we know the 2 is stretched higher. So for example, if I wanted you to stretch from log base 2 to log base 4, it'd be getting what? Smaller. Because the log base 4 is flatter. Okay, does that make sense? This is the part they're going to write. It's a little confusing, so I'm trying to get you to understand. Okay, so this is what they're asking. About the x-axis, state the stretch factor and complete the statement. So log base 4 of x equals what times log base 2 of x? So we know log base 2 of x is stretching faster. So we're going to be making this one smaller, right? So how do you make things smaller? Fractions, right. We're going to be, that's our numbers between 0 and 1. Okay? So then from 4, what do you notice between their y values? 3 to 3 halves. It's 1 half. 1 half of log 2's, what's 1 half of 3? 3 halves. That gets you to be log 4. See how it was less than 1? We shrunk it. Okay? This is the really confusing part, so please ask questions. I understand it's not like, it's fractions 1, and it's weird, again, because you expect log 2 to be a smaller stretch, but it's a bigger stretch. Okay? See, log base 2 kicks out a 3. Log base 4 kicks out 3 halves. See the relationship? In order, read it this way. We know log 4 of x is what? 3 halves. To make log 2 be 3 halves, I have to times it by 1 half. That's what we have to do. Okay, let's do now. We got a couple more. So now let's think about from log 8 to log 2. Log 8 to log 2. So what do I have to do to log base 2 to make it log base 8? Okay, question. Is it getting bigger or smaller? Log 8 is smaller than log 2, so we need to make this smaller. So we're going to do 1/3. Again, why is it 1/3? What is 1/3 times 3? It's 1. That's the stretch to get from log base 2 to log base 8. Yep.
So basically the log, like whatever the base of the log cubed or distributed.
Yep, so he's seeing it before you guys are right now. Okay? 2 to the 1 power, 2 squared, 2 cubed. So 2 squared, 1 half, 2 cubed, we 1/3. He's seeing the pattern. He's on it. Okay? That's where it's coming from. It's not going to be changed. You don't have to make a list every time and see what the change is. Okay, so that's good. Okay, we're going to keep going. If you're confused, it's okay. We got a little more time. Use the results above to determine the transformation. Okay, which would map log 2 of x to log 64. So now this is what Jake was just helping us with. We don't need to do log 64. We know that 64 is 2 to the what? 6. So then what goes there? 1/6. Good job. Okay, so here's the rule that we just kind of came up with. Transformation which maps log b of x to y equals log b to the n. See, this is what Jake's talking about. B to the n. Once you notice the base is a vertical stretch of 1 over n. Okay? All right. So we can probably finish in about 5 or 6 minutes here. So again, if you guys want to go, you can at 45, but I'm just going to keep going like I said. Okay, so right here we got y equals log 3 of x to the graph y equals log 81 to the x. So we want to get these to go to the graph of log 81. So that means we're taking this one. Is this going to be shrinked or expanded? Shrink, because we want this one to go to that one. This one is 3 to the 4th, right? So it's 1/4. Now look at this one. 16 to 4. No longer shrink. We need to expand, right? We need this guy to get bigger. Do you guys see the difference? 3 to 81 versus 16 to 4. Okay? 16 is 4 squared. This one's 4 to the 1, so we're going to double it. Double 16 to get to 4. Why is it not 1/2? Because we're getting bigger. We need it to get bigger. Okay? And so this is repeating what we just said. Log 81x equals 1/4 of log 3x. Log 4 of x equals 2 log 16x. Okay, a couple things, guys. This is kind of cool. Well, actually, I won't do that right now. I don't want to get you confused. We'll stay where we're at. All right, let's look at these. Last page. Okay. So if log 5 of x equals 6, take the value of log 125 of x. Okay? So what do we want to do? Well, we want to get log 125 of x. How will we write that? Well, we know it's what's that?
Like the 5, like the log 5 would be like a third, so it's really small.
Right. So this one, yeah, okay, so you already kind of,
Third of x, 6 then?
yes, that's essentially what it'd be. So, but what you would do is you would write it like this. So Jake's doing it. If you guys are lost, it's okay. He's seeing this right here. 125 is 5 cubed. That's what we need to know. So then you do know that in order to log 15x, it's going to be 1/3 of this is going to get me that, right? 1/3 of this gets me that. Well, we know what that value is. What is this value? 6. So then 1/3 of 6, like Jake said, is 2. So 2 is the answer there. Okay, I know it's fraction city. I know it's hard. Okay. Again, just focus on, as they say, if you can just focus on which one's stretching faster. This one, 5 is stretching faster. That way you know which fraction to use or not. That's the order is really important today. Okay, so if you can get that down, we can touch up the rest. Prove the result in converting the exponential form. So they just want us to go, if you do this, you get 5 to the 6 equals x. And then if we do 125 squared equals x, they should equal up, and they do. Okay, where did I get the 125 squared? Because we said this equals 2, right? So I did 125 squared equals 5 to 6, and they do match up.
Junior class change.
Okay, I just have this last example. Like I said, do what you want, it's fine. Okay, so here, we use the knowledge learned in transformations to compare these two. So strictly, I'm just going to show you that, guys, x minus h, that still means opposite. So move right or move left. K still means up or down. B still means horizontal stretch. A still means vertical stretch. Okay, so all that stuff's same. So then we come down here, okay, without having to do that in your calculator, you guys should know what's this going to be? 2 log base 3 of x. Vertical stretch of 2. What's this going to be? Right 2. What's this going to be? Down 2. That's it, right? Okay, and then let's just answer B and C, and then we'll get out of here. Okay, do any of these above transformations result in change in the original domain or range? Remember, so logs are, what's our issue? Our issues are with our x values, right? So this one, no change. Change, we shifted our right 2. So now this one's is going to be x greater than 2, not 0 anymore. Okay, and so that would be x equals 2. This one's still x equals 0. No change. I'm just writing it straight down here. So,
please excuse the interruption. Would Mr. P.
And then last one here. Does this one change at all by moving it down? No, because our y is all reals. So moving up and down the all reals doesn't change anything. So this one right here would be still no change, and then x equals 0. All right, perfect. Thank you so much.